Ninja mode, bro. So today we're going to do problem 2420. Find all good indices. I hope everybody had a good weekend. I hope everybody's survived these massive tech layoffs. If you're looking for a role, you've been laid off, I feel for you. I've been there. I don't think you really earned your stripes in tech. You haven't earned your stars, your stripes, your badge, whatever, until you've been laid off at least once, because that's booming and busting. Anyways, let's get right into this problem. 2420. Find all good indices. So you're given a zero-indexed integer array nums of size n, okay, and a positive integer k. We call an index I in the range k to I to n minus k good if the following conditions are satisfied. The k elements that are just before the index I are in non-increasing order, and the k elements that are just after indexed I are in non-decreasing order. Okay. Return an array of all good indices sorted in increasing order. All right. So there's this array, right? Some general array with elements A, B, C, D, E, F, G, H, I, and J, right? And you have K equals whatever, right? So you have some K value. And for that K value, right, if you have K equals X, so maybe X elements, right? So this indice is good, E, if the X values that come before E are non-increasing. So that would mean that they have some form like this, right? And the K elements, why'd I call it X? Just call it K, that's fine. K is already a variable. So the K elements before are non-increasing, and the K elements after are non-decreasing, right? So that could mean like it just never decreases, right? So it's some sort of stepping stone. And this would be a situation where, right, that this is a candidate for the solution. So let's look at an example then, I guess. So if we had nums equal to 2, 1, 1, 1, 3, 4, 1, 3, 4, 1. This is saying that the good indices are 2 and 3. I guess the first thing we should note is we have to mark off, like, automatically the edges, they can't be solutions, right? Like this can't be a solution because there's no K elements to the left, right? So there has to be K elements to the left to check, right? And I know that because of this condition here, K less than or equal to I, right? So we have to start at the Kth element and we can't look past K elements to the right, right? So these are automatically X'd out. Like we can't try these ones or this one, right? Because you have to have K elements to the left to check and K elements to the right to check. All right. Now, the conditions are pretty simple, right? K elements to the left, non-increasing, and K, we'll do a different color. K elements to the right, non-decreasing. So since these are all kind of small, it can be kind of helpful to just draw this out as a graph just for the sake of doing it, because it just looks kind of cool, I guess. Just helped you to visualize 1, 2, 3. Right, so if I look at each of these numbers, right, so we have 2 is the first number. I guess it should actually start here. 2, and then 1, and then 1, and then 1. I'm literally just graphing these points out. 3, and then 4, and then 1. All right. This is just to help us kind of see what's happening here. Right, so the solution says, right, so we have these indices. So this is indice 0. Let's actually use So 0, 1, 2, 3, 4, 5, and 6. Right, 0, 1, 2, 3, 4, 5. Okay. Now this is saying that indice 2 and 3 are solutions. Well, why is that? Well, when we look at indice 2, right here, we have to look at k to the left and k to the right. We have k equals 2. So are the k equals 2 to the left non-increasing? So this decreases and stays the same. So yes. And then are the k to the 2, k equals 2 to the right non-decreasing? Well, this is non-decreasing and this is non-decreasing. So yes, so that's a solution, right? Now let's look at 3. So are the two things to the left non-increasing? Well, this is non-increasing and this is non-increasing, so yes. And are the two to the right non-decreasing? This is non-decreasing and this is non-decreasing, right? Versus, so that's also a solution. Now 3 is not a solution. Index 0, 1, 2, 3, 4. Index 4, right? This 3 is not a solution because, well, to the left, are they not increasing? No, right? This is non-decreasing, but this is increasing. So it's not a solution. Same here, right? Because the left is non-increasing. So both conditions have to be true in order for this to work. Right now, the brute force solution would be to look at each element and then look at the k elements before and look at the k elements after and then see if that's a solution. So that would be n times k time, right? Because you would, every element, there's n elements, you'd have to look at negative k elements and positive k elements, so 2k elements, but big O of nk. So 2k elements for each element, there's n elements, so that's big O of nk. Now there's a faster solution. Now what's weird is that this has been classified as a dynamic programming problem, but my solution feels more prefix sum-y kind of esque. So how would that work here? Well, for every element, right, we just need to know if the previous k elements were increasing, right? So we need to have that information, if the previous k elements were increasing. So we can look at this system, or if the previous k elements are non-increasing, sorry, right? For any element, we just need to know information about the previous k elements, right? So is there a way that we can catch that information, that we can save that information without having to recalculate it over and over again? Well, what we can do is to see if the previous k elements are increasing is just keep a running sum, right? And every index for how many of the previous k have been increasing, right? So when I look at this, when you start, there's always one thing that's increasing, right? Just yourself. That's non-increasing. This is non-increasing, so that's 2 things in a row that are non-increasing. This is non-increasing, so that's 3 things in a row that are non-increasing. This is non-increasing, so that's 4 things in a row that are non-increasing. Now it breaks, right? Because this is increasing, so now there's 1 thing in a row that are non-increasing. It breaks again, so there's 1 thing in a row that are not increasing. And then it goes down. And there's 2 things in a row that are not increasing. So to summarize that, we could have this non-increasing array, I'll call it ni, which just tells you the number of things that are not increasing in a row at that point. Right, so the first thing, there's 1, and then 2. So from 1, from here, there's just 1 thing that's not increasing because it's just itself. This is not increasing, so we have 2, not increasing, so 3, not increasing, so 4, increasing, so 1, increasing, so 1, decreasing, so 2. All right, now let me make sure that makes sense. 2 to 1, not increasing. 1 to 1 non-increasing, 1 to 1 non-increasing, 1 to 3 increasing. Okay. And then, so that means we have the information for the k previous things, right? So if I would just blindly look at this element here, right? I don't know this index, 0, 1, 2, 3. So we have these IDXs, so just to make it clear, 0, 1, 2, 3, 4, 5, 6. So if I look at index 3, right? I know that to my left, without having to recalculate it, I can say there's 3 things to my left in a row that are increasing, right? Because that's how I calculated this, right? Because every time something was increasing in a row, we kept adding 1. As soon as it broke and it became non-increasing, it became no longer non-increasing, then we had to restart that running sum, right? So I know here for sure that there's 3 elements in a row that meet the condition of being non-increasing, right? If I look at this point here, I can say for sure at this point, there's only 1 element in a row that are non-increasing. So I have the left thing solved, right? I have the left condition already solved just by looking at 1 element in non-increasing, right? Because it keeps that information in a row, right? Because it collects again, I'll write it all out here. So this is 1, 2, 3, 4. 1, 1, 2. Right? So just by looking at this sum, when I look at this element and I want to say to my left, is it non-increasing? I could just look at its left element and make that decision. Right? Or when I'm looking at 3, I can say, okay, to my left, is there at least k elements that are non-increasing up to this point? And that's what this 3 would give me, right? Because that 3 keeps information about the number of elements up to this point that are non-increasing, right? So what non-increasing gives you is the number of elements in a row that are non-increasing up to this index, right? So when, again, just to be crystal clear, when I look at index 2, which is 3, right? So when I look at this index, all I have to do is look at the information to the left, and that'll tell me the number of digits up to that point in a row that are non-increasing. So I can play the same game for non-decreasing points, right? So what we should also do is have a non-decreasing array. So 1 to 1, right? There's 1 thing that's non-decreasing. This is decreasing, so now it's 1 again. This is non-decreasing, so now it's 2. This is non-decreasing, so now it's 3. This is non-decreasing, so this is 4. This is non-decreasing, so it's 5. This is decreasing, so it's 1. Right? So I'm just keeping a running sum. Like I'm gaining momentum every time the condition is met. And then I'm gaining momentum every time the condition is met. And then when the condition is no longer met, I have to restart. Right? So that will give me information about things non-decreasing. Okay? So if I want to say, I want to look about information to my right. Right? Now I'll redraw this. So these are the non-decreasing points. If I want to know if I have k elements to my right that are non-decreasing, well, that would mean how many elements do I have in a row k to my right that are non-decreasing, right? Because the information at this point, if I'm looking at index 3, right? 2k equals 2, so 2 to my right will tell me the number of points in a row that are non-decreasing. So if 2 to my right, the number of points in a row is greater than 2, right? If the points that are k to my right have non-decreasing elements in a row that are greater or equal than k, that means that those k elements to my right at least are non-decreasing, so it meets the condition. So if I look at any index, right, so I'm non-decreasing, increasing, using just these 2 arrays. So I have my indexes, right, which are 0, 1, 2, 3, 4, 5, and 6, I guess. For any index that I can check as a candidate, right, so if I look at index equals 2, so if I look at index to equals 2, what has to be true? The k elements that are just before index I are non-increasing. So that would mean that I look at this and say, okay, is there at least k elements to the left of me that are not increasing? And this would say yes, because there's 2. And I have to look at the k elements that are after I to see if they're non-decreasing. So k elements after I would be up to this point and say, is there at least k elements that are non-decreasing in that direction? And yes, there's 4, right? So what I do is say for any index, the index is a candidate if what? If non-increasing at idx minus 1 is greater than or equal to k, so there's at least k elements to the left, and non-decreasing at idx plus k is greater than or equal to k. So that means to the right, non-decreasing as well. So with that, let's go ahead and write the solution. So I hope that that makes a little bit of sense. It's kind of a prefix sum idea, right? And you can and you can kind of determine that, right, because it's very similar to this idea that using prefix sums, which is like the number of things in a row that do something, right? Because when you think of in a row, if something in a row has to be happen, like a direct subarray of the array, right? That means that there's information that has to happen in continuum, right? It has to continue to be true. So like 1, 2, 3, not a subsequence, a subarray. I'm rambling here, but that idea of it being a subarray, right? Because there's a subarray, the from any index, the subarray that's negative k from that index, right? Like if I look at, right, if I look at this element here, I have to look at the subarray that's 2 to the left and the subarray that's 2 to the right. That kind of indicates to me that we're probably going to be using prefix sums in this problem. Okay. And then you can just kind of catch those prefix sums and then use that information to quickly iterate through. So this takes the solution down from nk to just n. So we removed that k coefficient by doing this. So let's create that non-increasing and non-decreasing arrays. Now, every element, right, is itself a length 1 non-increasing or non-decreasing array, right? Like just by itself, everything is at least 1, because an element by itself is a length 1 non-increasing or non-decreasing array. So we'll create arrays for both of these things. And then how will we populate it? But so we'll look at each num. Actually, no, we'll look at I in range 1 to length of nums. So each index. Now we don't need to look at the first one, right? Because the first index is always 1 because there's nothing before it to compare it to, right? When we look at this element here, right? This element, there's nothing to the left to compare it to, so it's always 1, right? It's always 1 in non-increasing or non-decreasing, right? The first element, index 0, is always 1. So we don't need to worry about that. So non-increasing at I plus equal, it's going to, if it's increasing by 1, you're going to plus equal the previous element's value, only if the nums at I is what? What does it mean to be non-increasing? If it's not increasing, then it's less than or equal to the previous element, right? So this will be 0 if it's not true, and we won't increment n of I non-increasing at all. If it is true, then we will increment it by 1 every time. And then we can play the same game with I, but the condition is a little bit different. What does it mean to be, why did I call it empty? Non-decreasing. What does it mean to be non-decreasing? Non-decreasing means that the number is either getting larger or staying the same. And then why did I do it like this? So I can be a fool who makes everything really confusing and on one line. But I'm just doing this because I have problems. All right. So non-increasing of I equals non-increasing of I plus this if this condition is true. Non-decreasing of I equals non-decreasing of I plus this if this condition is true. All right. Atrocious. Okay, and then now we want to go through our array. So what we return is we return each index for each index in the range. Well, remember, we have to start at k because there's not enough elements to the left, right? Remember, it says it has to be within this range. So it has to be in the range of k to n minus k. So n is the length of nums minus k. So I'm just taking this directly from the prompt, but also it intuitively makes sense, right? Because you can't, like, there's not k elements to the left of index 0. So it has to be within this range. If what? Remember in this problem we said, right, so for index 2, we checked the previous index to make sure it was non-increasing. So if the previous index minus 1 is greater than or equal to k, and we had to check plus k indices to the right to make sure that there's at least k non-decreasing in that orientation. And non-decreasing index plus k is greater than or equal to k. So this will look at each index and it'll only append it if it meets the condition, and then this will naturally be in order, right? Because we're looking through each index in order. Okay, and let's go ahead and submit that. And there you go. So what's the runtime of this, and what's the space time? What is the space time? Okay, so the runtime, we have to build 2 arrays of length n, so that's 2n, and then we look at n numbers, right? So that's going to take n time, and then we look at each index. Technically, we go from k to n minus k, so there's n minus k indices we have to look at here. So it's n time here, and 2n time here, n time for this for loop, and n minus k for this. So in total, that's the big O of n, where n is the length of nums. And then for space, we have to create 2n space for this, and then we populate that, so that takes constant space. And then we have to return an array, which is at least of size n minus k. But it takes 2n to create this, so on time in on space. And yep, that's it. So I hope this was a little bit helpful. Hope you guys enjoy the rest of your day.